We're good.
Good.
Porque
So we're standing here in front of our latest prototype for a Istanbul Visiting School. 4 days ago there was nothing, and in 4 days we built the Istanbul this prototype. Just to give some brief background, this visiting school is a collaboration between the AA and Istanbul Bilgi University. It's our 4th year this year, and we're very happy to be collaborating together. This year we've explored robotic hot wire cutting techniques, and we've looked into ways of correlating robotic hot wire cutting with formwork with no waste, basically. So what you see here is basically we've covered our EPS blocks that were cut by the robot with GRC, with concrete spraying techniques. And then we rolled the GRC, so we covered it with a final coat that has no fiber. Just to talk about the process, this is a 12-day workshop, and we've had 31 students this year, and these are our tutors. We're missing 2 tutors actually, so we say hi to them as well. And how we organize the process is that we have design teams of 4 or 5 students every year, and they develop their design ideas, design concepts that are focused around the main research agenda that I've just described. And they come up with their design options. We have daily sessions, obviously, where we discuss with them their ideas and how they kind of proceed with the proposals. This is also fed by software tutorials. We work with advanced software, coding as well, and obviously robotic fabrication.
Hi, we are Robotic Code, and our part was actually processing the code. We began with that cube, and then afterwards, our code was basically terminating the cutting surface, and afterwards, we had to, when it's cut, we had to put them together in that way. So we had our component. Of course, it was different in every angle, and we had every component was different than the other one. So afterwards, we sent it to the robots, and then we had this part, and then afterwards, we actually had to label them accordingly because every cube has different label. So we labeled them on the front and on the top, and then they had to come together, and it was basically that much. Of course, there are other stuff that we did. We did everything, but yeah, that was it. Yay!
Okay, so we designed 2 kind of jigs to cut the boxes. The one is 33 by 33 degrees, and then the other one is 15-degree angle.
And we finally formed this shape to cut the pieces with 15 degrees and easily form the shape like a curvature.
Alright, so we are the robotic fabrication team, and what we're doing at the moment is we're setting up the cube for cutting by the robots. We have designed a ruled surface that will dictate the cutting. So what the robots will do is cut this surface off from this cube, and basically we will generate something like this, which is the design, and we will have to tag the top and front and essentially glue the 2 pieces together to form the pavilion that we're going to design and fabricate.
Finally, we decided to settle on an idea where we would put a sheet of plastic onto the gravel, then we would put soil, and then we put packers inside to level the field, and then on top of that we put a layer of pink foam, styrofoam. This foam, this wonderful, beautiful pink foam, very tasty. And then after that we put another layer of plastic, after which we had the components which we then covered in concrete so that it was more stable and it was solid. So finally we had a very stable connection to the ground, and we have a very level playing field. Everything is A-okay. And then we even have a little dance for you. But no, actually don't.
Okay, so this is basically the touch face of the cube to the wall. So it generates those lines so that the cube can be on this location exactly when it meets the wall.
We are the wall connection team. We designed this L-beam for a wall connection. We pinned this side, the upper side, to the wall, and the underside carries a load of the model. And to strengthen the whole construction, we added these 3 other L-beams. So that's it.
As the assembly group, our job was to assemble all of these pieces by using these templates. And then in the studio, we stacked all the pieces together. We had to bring them outside and also used a template on the ground so that they all aligned perfectly. And then with the larger blocks as the columns, we then put together all of the arc and attached it to the wall.
Okay, so we are the analog rolling team, and we have generated some rollers which we can use on the surfaces of the blocks that we have created. And for the experimentation, we kind of started working with the wood. And these are some of the 3D printed prototypes that we are going to be using on these rollers to generate a pattern on the surfaces.
We are a lighting group. We are still trying to light it up by LEDs. So firstly, we tried the colors and the lights on some renders, and we showed the group how we did it, and we let them choose which one is better. And they decided on something that we can build, so we got the LEDs, and now we're trying to build them on the real structure. That's our aim. That's what we do in this project.
What's going on here? Where we are moving the bench to the place. Okay. It was a little bit difficult, but we made it. We need to make some corrections over there, but yeah, that's it. We did it.
We're cleaning the site.
Yeah, we're cleaning the mess right now.
I just want to say a couple of words about Fibrobeton, our sponsor and supporter this year. Fibrobeton has been involved with research and development for many years. They have great expertise in complex formwork generation and GRC application. And this year they have supported us with their workmanship, materials, and especially know-how. They have been part of the workshop organization process from the beginning, and they have been incredibly helpful and supportive with their involvement.
So here we are with you with our prototype.